Okay, so this is the second order differential equation that we're going to solve through matrices. So the first thing that you want to do is you want to move everything that's got the lower derivatives to the other side. Okay, so y prime prime is going to equal 6y plus y prime. And so the matrix that we'd be dealing with is y prime, not prime, is going to equal 0, 1, 6, 1, y prime. Okay. So this is just like in class like we did last time, is that first you're going to find the eigenvalues, then from the eigenvalues you're going to find the eigenvectors, and then once you've found the eigenvectors, you're going to look for the coefficients based upon the initial conditions. So let's start out by just finding the eigenvalues. Okay, so to find the eigenvalues, we're going to take the determinant of a minus lambda I, and we're going to set that equal to 0. So let's take the determinant of that. Well, 0 minus lambda is just negative lambda. That's 1, that's 6, and that's 1 minus lambda. So let's take the determinant of that. So that would be negative lambda, now multiplied by 1 minus lambda, and then minus 6, which would be negative lambda plus lambda squared minus 6. Well, that's lambda squared minus lambda minus 6. And if you look at this thing, that lambda squared minus lambda minus 6, that is the auxiliary equation. I mean, look at it. Lambda squared minus lambda minus 6. And our equation is y prime prime minus y prime minus 6y. Okay? So looking for the eigenvalues is the same thing as looking for the roots of the auxiliary equation. So what are we going to get from this? This is going to be lambda minus 3 and lambda plus 2. And we're going to close that parenthesis, and that's going to be equal to 0. So our lambda 1 is going to equal 3, and our lambda 2 is going to equal negative 2. Okay? So we found the eigenvalues for our problem. That was our first step. Okay? Now we're going to go to our next step, which is going to be our eigenvectors. Okay. So, step 2. Okay, so we're going to solve a minus lambda 1I v1, which equals 0. Okay? So let's look at a minus lambda 1I. Okay, so we picked a lambda 1 to be 3. So 0 minus 3 is negative 3. That's going to stay as a 1. That's going to stay as a 6. And this is going to be 1 minus 3. All right. So, well, let me just simplify real quick. Negative 3, 1, 6, 1 minus 3 is negative 2. Okay. Now, this happens on all of these problems. Once you find the eigenvalues, your matrix, when you look at A minus lambda I, ends up becoming a linearly dependent matrix. And what do I mean by that? Is that if I took the top of this thing and I multiplied it by 2, what, I get negative 6 and positive 2. They would completely cancel out the bottom. So I can completely kill off the bottom, which basically just means it leads to a null space, and your eigenvector is the null space. So set 0 and 0. All right. Now I'm going to divide by -3 because I like it to be in reduced row echelon form. All right, now this is going to act on B1, and it's supposed to produce 0 and 0. Okay, so this is the free variable, and so what is this thing right here really saying? That x1 minus 1/3 x2 equals 0. Okay, so that means that x1 actually equals 1/3 x2. So v1 would equal 1/3 and 1. Right. All right, now let's find v2. Okay, so we're going to solve a minus lambda 2I v2, which is going to equal 0. All right. Now, what was my lambda 2? My lambda 2 is -2. Okay. So, a minus lambda 2I, okay, that's going to come out to 0 minus, well, -2. Okay, and then that's a 1, that's a 6, and this is 1 minus -2. Okay, so that becomes 0 minus -2 is just 2, that's a 1, that's a 6, and 1 minus -2 is a 3. Okay, we can eliminate the bottom again, and so this becomes 2, 1, 0, 0, and you know what, I can divide by 2 because I like to do that. So 1, 1/2, 0, and 0. Okay, now this is going to act on v2, and it's supposed to equal 0 and 0. So v2 is going to equal negative, well, the bracket right there, -1/2 and 1. Okay, so we've gotten to our v2. All right, so step 3. We need to find C1 and C2. Okay, so what we have so far is that now y prime is going to equal C1, and I picked 3 for the first one, e to the 3t, and then multiply by v1, make sure you associate the correct vector with the correct eigenvalue. So that became 1/31. Okay? Okay, now plus C2, e to the minus 2t, now multiplied by -1/2 of 1. All right, so this is where we are at in the problem. And so we need to find C1 and C2. So to find C1 and C2, we need to use the initial conditions of the problem. So what were my initial conditions? We have y of 0 equals 1, and y prime of 0 also equals 1. And so remember, when you plug 0 into the exponential function, it just goes to 1. Okay, you do the zeros 1. So we're going to form this into a matrix, and what it's going to come out to is 1/3, 1, now -1/2, 1, now acting acting upon C1 and C2 is going to equal 1 and 1. Okay. But I don't want to repeatedly write C1 and C2 over and over and over again. So I'm going to draw this as an augmented matrix. So, look like this. 1/3, 1, negative 1/2, 1, augmented, 1 and 1. Okay, so the first thing I need to do, I need to multiply by negative 3 and add downwards. So that would be 1/3, and then negative 1/2 and 1. The top's not going to be influenced by this. Okay, so if I take 1/3 and I multiply by negative 3, I'm going to get negative 1. Negative 1 and 1 will cancel out, that'll be 0. Okay, but now when I take this one, if I multiply this by negative 3, I'm going to get positive 3 over 2. Positive 3 over 2 plus 2 over 2 would be 5 over 2. Right? Now, negative 3 acting upon this one, that'd be negative 3 plus 1, which is a negative 2. Okay. You know, I could divide that by 5 and add upwards, but I think at this point, let's just go ahead and turn that end point into a 1. So, what we're going to do is let's just multiply by 2 divided by 5. Okay. So, that becomes 1/3, 0, negative 1/2, 1, and this becomes negative 4 divided by 5. And this is going to stay as a 1. Okay, so at this point of the problem, we need to eliminate the negative 1/2. So we're going to multiply the bottom row by 1/2 and add upwards. So that would give us 1/3, 0, 0, 1, negative 4 divided by 5. Now we have to consider that position over there. So if I take negative 4 over 5, and I'm just multiplying this by positive 1/2, so if I multiply this by positive 1/2 and add it to that one, they cancel each other out. So if I multiply this guy by positive 1/2, it's going to give me a negative 2 over 5. Wow. And negative 2 over 5 plus a 5 over 5 is a 3 over 5. Okay. And, we're still not all the way there yet. Let's multiply this guy by 3. And so we're going to get 1, 0, 0, 1, augment, 9 over 5, negative 4 over 5. And so C1 equals 9 divided by 5. And C2 is going to equal negative 4 divided by 5. Okay, so let's write down everything that we've got so far. So we have, this is what we've got so far. Y and Y prime is going to equal, okay, so my C1 is 9 divided by 5. And that's going to be C1, sorry, that is C1. E to the 3t, now multiplied by, this was positive 1/3 and 1. Okay, and then a negative 4 divided by 5. Okay, that's multiplied by e to the minus 2t, and then multiplied by negative 1/2 and 1. Okay. So when I multiply 9 divided by 5 onto that one, I'm going to get That's going to be 3 divided by 5 e to the 3t. This guy down here is going to be 9 divided by 5 e to the 3t. Okay. Now this one's going to be multiplied by negative 4 over 5 and a negative 1/2, which will turn that into a positive 2 over 5. 2 divided by 5 e to the minus 2t, and minus 4 divided by 5 e to the minus 2t. Okay. All right, so the questions that you need to ask yourself at this point of the problem is, one, is this the derivative of that? Because you're finding y and y prime. And so if I took the derivative of this guy, is it this? Well, if I took the derivative of e to 3t, it'd spit out a 3, and yeah, you get 9. So if I took the derivative of this, well, it would spit out a negative 2, and it would become negative 4. Okay, the next thing that you need to think about, does it actually match the boundary conditions? So this said that y of 0 is 1 and that y prime of 0 is also 1. Well, if I plug in 0 into this guy, 3/5 plus 2/5, yeah, that's 1. All right, and then the next one is 9/5 minus 4/5 would just be 5/5, which it is 1, okay? So, A, we know that it is its derivative. B, or 1 or 2, B. I'm making too much of this. B, it satisfies the initial conditions. It solves this. All right, the only last thing we need to do is we need to check and make sure that it actually solves the differential equation that we were dealing with at the very beginning of the problem. We don't have to check this one right here. So, going back to the beginning of this problem, what was the differential equation that we were dealing with? This is going to be y prime prime minus y prime minus 6y, and this is supposed to equal 0. Move that up a little bit. So we need to verify that this solution right here actually satisfies this differential equation. Okay. So we're talking about that top y. So if I talk about y prime, y prime is going to be 9, y prime prime is going to be 27. So that's going to be 27 divided by 5 e to the 3t. Okay. All right. Now this next one, we're talking about the second derivative. This is the first derivative right here. If I take the derivative of this guy again, it's going to spit out another negative 2, turning this into a positive 8. So that's plus 8 divided by 5 e to the minus 2t. Okay. Now minus, okay, let me just write that one down. 9 over 5 minus 9 over 5 e to the 3t minus 4 over 5 e to the minus 2t. Okay. And then minus 6. Okay, so that would be, I'm going to run out of room. Try to write it smaller. 3 over 5 e to the 3t, and then plus 2 over 5 e to the minus 2t. Okay, I have to put that on there. All right, so let's look at this. So we've got 27 divided by 5 e to the 3t, and plus 8 divided by 5 e to the minus 2t. Okay. Yep. Okay. Now minus 9 over 5 e to the 3t, and plus, now 4 divided by 5 e to the minus 2t. Okay, then this becomes minus 18 divided by 5 e to the 3t. And the negative 6 and the 2 becomes a minus 12 divided by 5 e to the minus 2t. Okay, now I know that looks really long and messy, but let's isolate our individual points. So the e to the 3t's, we got a 27 over 5. And so just pay attention to the 27, okay? We got a 27 and a negative 9 and a negative 18. So that's 27 and negative 27. So okay. Now we look at our e to the minus 2t. So we have an 8 over 5. All right, so let's ignore the over 5s right now. So we have an 8, a 4, and a negative 12. So that's really 12 minus 12. Those guys cancel each other out. So we know that we got to the correct answer.